All right, what's up, algebra? Today we are doing 4.7, which is sequences and functions. All right, so basically I'm going to have you start out just as sort of a warm-up for yourself and just a refresher. You're going to go ahead and do 1, 2, 3, and then, yeah, that'll be it for that one. All right, so go ahead and do those three really quick, and then we'll come back together. All right, once you've done those, you're also going to go ahead and look at 11 and 12. We talked about this a little bit before our last test, so go ahead and look at those really quick. And I want you to try to come up with an example of one that would be discrete and an example of one that would be continuous. All right, so go ahead and try that as well. All right, and then lastly, I've got a little bit more for you to do. We're going to go here on, this part's actually, I think it's actually in your book, but we're going to look at 1, 2, 3, and 4 on this page as well. So more examples for you to do before we really get started on the notes. Go ahead and try them out. And I think that's all the examples before we really start actually getting into things. So go ahead and try those as well. All right, so getting into the actual note stuff, a sequence, all right, that's what this is over, is an ordered list of numbers that often form a pattern. So basically it's just numbers in a pattern. Each number in the list of those in a sequence is called a term of the sequence, all right. That's just some terminology that you're going to see as we're going along through this. All right, so yeah, that's basically what you needed to know about the actual vocabulary term sequence. Kind of cool, the origin from the Latin word sequentia, which means to follow, which is, I think, makes sense because we're following a pattern here, right? So that's kind of what a sequence is, okay? So looking at problem 1, we have this got it problem, even though we haven't really done a whole lot yet. Describe a pattern in the sequence 5, 11, 17, 23. What are the next 2 terms of the sequence? All right, so it asks us to kind of show what happens in between them, right? So on this one, on the first one, we're doing 5 to 11, that's plus 6. 11 to 17, that's plus 6, and 17 to 23, that's also plus 6. All right, so if we were to describe that pattern in the sequence, we're going to add 6 to each term. All right, and if we use that for number 9, we could find the next 2 terms. So 23 plus 6 would be 29. 29 plus 6 would be 35. Okay. Moving on, we then have problem 2. All right, so for problem 2, we're looking at arithmetic sequences. Okay. Sorry, so I forgot where I was. I got distracted a little bit. So for number 2, we're looking at an arithmetic sequence. All right, arithmetic, basically, all you need to know is that arithmetic sequences, okay, they just have a common difference. All right, that's really all you need to know for now on arithmetic sequences. Okay, and then you will get more into arithmetic sequences when you get to Algebra 2. But really, as far as they go for us, this is, I mean, we're not going to focus too much on writing equations for them just because that's Algebra 2 standards. All right. So yeah, but we will look at kind of how you solve them. All right. So we have consecutive terms is the, I guess, x value, you could say, if this was a table that was x and y values. So the consecutive terms, we have 8 and 15. then we have 15 and 22, then 22 and 30. Okay, and then we got to see if there is a common difference. So 8 and 15, the difference is 7. 15 and 22, the difference is 7. 22 and 30, the difference is 8. Okay, so it asks, do they have a common difference? That would be no. So no, it's not arithmetic. All right. Go ahead and try out 13 and 14 on your own. Pause the video and we'll come back into it again. All right, so we're going to look now at writing nth terms. All right, so for nth terms, your first step is to give each number terms I guess a sequential number, right? So for this one down here that we're looking at, 3 would be the first term, 9 would be the second term, and those are listed right here for you. All right, so after step 1, you're going to look at step 2, which is to multiply the constant difference of terms times n. Okay, so you can see here we're going up 6 plus 6 plus 6. Okay, so the constant difference of terms, which is 6, you're going to multiply that by n. Okay, and then your third step would be to add the 0 term. Okay, now we don't have a 0 term, right? So that's one that you would need to find. Okay, so if we're going up 6 each step, the way that we're going to get from this step 0 to 1 is going to be to add 6 as well. All right, so if we subtract 6, since it's the opposite, that's going to help us find our 0 term, which is going to be -3. All right, so you're going to add that term, so -3. Okay, so you should end up with an equation a to the n, or a of n equals 6n minus 3. All right, so you'd put that right here. Okay, and then you can use that to find out what that a of 10 is. All right, so we would do a of 10 equals 6. And then for every n, you're going to plug in 10. Okay, and we've got 6 times 10 is 60, minus 3 is 57. All right. So go ahead and use that. And I'm going to have you try out Got It problem on 4, number 21. You're going to do all of that. So you're going to find the term number, the a of n, and then the n, and then you're going to find the rule. And then lastly, you're going to find the value of the pass after 15 rides. All right. Once you've done all that, you are good on this video lesson. Yeah, good luck with that. And then we will talk about it in class and continue to work on it there. So I'll see you guys then.